welcome to the C# Basics in Unity P2P workshop. My name is Dion, and I'm the Game Engine Guild lead of Next Lab. So today I'll be going over some very basic programming with scripts in Unity. So this workshop does assume that you have a baseline knowledge of how to use the Unity editor and what that is. So I will not be explaining that. So before we get into the actual workshop content, if you are following along, I'd like you to open a Unity project that uses the universal rendering pipeline, because this maximizes compatibility with the package that I shared with you all. So, as a prerequisite, I need to poll the audience. Do you know how to, at the basic level, write code? Okay, if you know how to write code, then that's fine. If you know how to write code, then I don't have to go over the very, very basics, and I'll just jump right into the Unity stuff. So, of course, I'll still try to make what I explain as simple as possible. So, let's see. There we go. All right, so once you've entered your project, this assumes you know how to use the Unity editor. So we're going to go over how to make a script. So to make a script in Unity, it's pretty simple. You go to your project window, which is one of the tabs that should be default docked onto your Unity editor screen. Right-click within the project window and just do create C# script. And this will make a script that you can attach to the objects into your Unity scene. And you can code it to pretty much any behavior that you are capable of coding. So I'm just going to call this sample script because I'm not actually going to be using it for much. I'm just going to be showing the basic methods that I'm going to cover. So I'm just going to call it sample. And I'm going to open it. Oh yes, I suppose this also assumes that you have a code editor to edit your scripts in. So if you installed Unity, it should come with Visual Studio. If you don't, you can. One of the defaults in Windows should be like Notepad or something. But this one will use Visual Studio because it's the default that comes with Unity. Cool. So once you open a script, you should notice that it's basically blank, save for maybe 18 lines of code. Every script that you create initially in Unity will derive from mono behavior. And if you're not familiar with coding, that is what this colon in C# does. It means that this script sample is inheriting properties and methods from this script mono behavior. And most C# scripts will be like this. And anything that you create will default inherit from mono behavior. I will only be going over scripts that relate to mono behavior. If you're an experienced programmer, you know how to make scripts that don't derive off that and make them work. But for the purposes of this workshop, we'll be going over it like this. So the two important methods that come out of mono behavior are start and update, and they're conveniently placed for you right here. There are comments explaining what they do, but I might as well explain it myself. Start is a method that is called, when it says before the first frame update, it really just means a very, very short minute of time, or a very, very short amount of time after you start playing your game. So anything that you want, for example, to be initialized when you start your game or when you enter a new scene should be put in start. Update, on the other hand, is called once per frame rate that your game runs. So if your game runs at 60 frames, for example, update will be called 60 times per second. And these are done for, as the name might imply, values or methods that you want constantly running or updating as you play your game. And these are the basic, well, these are the most important methods to use when making a mono behavior derived script. So, I guess there's one thing I do want to cover, and that is a third function that's called awake. So let me type it out here. Got to put that on the mic real quick. Okay. So awake is another mono behavior function that acts similarly to start. The difference is that awake calls before start happens. So if you're finding yourself having conflicts with the code that you put into start, and that you need some code to specifically run earlier, awake is a good method to use in lieu of that. A lot of scripts also just forego start entirely in order to use awake, and that is helpful for making sure that certain things initialize before everything else in the project. So that's the use of awake. For the purposes of this demonstration, I'll just be using start, but just know that that is an option, and it's a very useful option at that once you get into more complex behaviors with your scripting. Cool. So before I go over some of the components and scripts to call, I should probably go over how the things you type in your script show up in the inspector, or might affect the inspector. So if you know programming, you know that there are basic data types in every language. And in C#, or in Unity, the most common ones that are being used are stuff like float or int, which represent numbers. So float FL, I'll just be simple here. Int, which is whole numbers, so IN. You have, int is an actual thing, IT. Okay. Strings, which are text. Boolean, designated as public. So if I put public here, you should be able to see all of these within the inspector. I'm typing with one hand, so this is really, really slow. Oh, that's nice. If you have autocomplete in your code editor, this will be very useful for you. So if I were to designate all of these public, which in programming terms is affecting the visibility of the variable, then they will show up here ready to be edited. And this is useful for when you don't want to go back into your code to edit specific values. There are inherent risks to using a publicly visible variable, but that is a topic for when you go into more advanced programming, and it's not something that I feel the need to cover right now. So just for now, know that if you set your values as public, you can put them here, and it will show you the name of those variables, so you know exactly what you're editing. Okay, now that that's out of the way, I should put the hotbar back. Now that's out of the way, I'm going to go over some common components and scripts to call. These are ones that I find myself referencing a lot, so it's useful to understand what they can do for you as a programmer. So aside from these, you can also designate other scripts. So if I wanted to reference another script called sample, for example, I can put sample here, which is informally known as the class or the type, and the name for that variable. So I'll call this SMP. And I'll be able to reference and call methods from another script, another sample script. So let's call that. The most common thing that you'll reference in terms of physicality within your game is the transform, which is, you might have noticed, which exists on every game object. So if you go to any of these game objects, they will have a transform, and you'll see that they have position, rotation, and scale. To reference a transform, so let me go back to the script. To reference a transform, of course, you can do what I just said and do transform. T, that's not spelled correctly. Transform T, and make it public, and once you save that, you can just drag the transform in here and reference it directly. But one thing that you can also do, and this applies to specifically the transform and the game object, which I'm about to cover, is that every mono-behavior script, or most scripts in Unity, will derive from a class called the game object, or object. And one of the properties that that class has, which you can access, is the transform. So if I were to reference this script itself, I would use the keyword this. If I press dot, that is called an accessor, and it's basically a way to get the properties of a script. So in this case, the properties of this script. If I were to type transform, then I'd be able to access it no problem. You'll see that I don't get, okay, I do get a red error. This dot transform. So if I designated, for example, this dot t equals this dot transform, and I went back to the inspector and started this scene, for example, you'll notice that when I play this scene, the t in this script will show up as game object, which is this game object. So this one proves that you can access the transform through any script that derives from mono behavior. And 2 shows how the start method works with setting this value when you start the game. So that's useful. Okay, cool. So with the transform, there are various methods and variables that you can access. The most common ones that I use when programming are as follows. Hopefully you can still hear me like this. Transform.position will give you the x, y, and z position of that game object as a vector, which is just a container for 3 numbers. And in this case, they represent the x, y, and z position. Transform.rotation will give you something called a quaternion. And this is an advanced math representation of an object's rotation, which I won't be covering, so I'll be showing a simpler way to access the 3 values in the inspector of that rotation. So that would be transform.rotation.Euler angles. And these will give you the x, y, and z rotation similar to the x, y, and z position. And lastly, there's also scale. Oh, local scale, I suppose. And that gives you the x, y, z scale of the transform. Cool. If you're familiar with Unity, you know that game objects can have children in the sense that you can drag an object under them. In order to access the child of a transform, you can reference the transform itself similar to a... You can access the children of a transform with an array, and that function is transform.getChildren? Or just getChild. So depending on how many children the transform has, you can designate a number that acts as the index of that child, if we're talking about a list. So in this case, if the game object had a single child, like if I put the global volume here, transform getChild with 0 as the parameter will return this game object, and you can reference that. So that's one way of getting children. Let's see what else. Okay. Those are pretty useful for transform. Now let me go over game object. So like the transform, with most scripts, you can access the game object itself, and that can be done with this.gameObject. Generally, this is just useful for accessing other scripts within that game object. So if you're referencing a different game object, you would use a command call or a method called getComponent. So getComponent is pretty useful for accessing the components or scripts of an object without actually having to reference the script directly. And the way this works is that you'd reference getComponent, and within these angled brackets, you'd type the class or type of that script. So if I want to reference a transform, for example, I just do transform. If I wanted to reference the sample script, I'd type in sample. And if I wanted to type in the game object script for some reason, I could type in game object. So that is how you use gameObject.getComponent. You can also access the game object's name and tag. So the name is what you name it in the inspector. And the tag is something that is a string that you tag it with in the inspector. And this is useful for certain checks or logic throughout whatever functionality you might want to bring to your game. Okay. And The last thing I want to go over for game objects is the function setActive and the reference game object active self. So setActive is a method that, well, quite simply sets it as active. And what that means in terms of a Unity game is whether or not the object is in the inspector, checked, or if it were a physical object, whether or not it appears in the scene. So if I were to, for example, disable the camera, you would no longer have a camera rendering the scene. And in this case, the camera game object is inactive. So setActive and active self are also useful for functionality, particularly if you want to turn something off after you maybe press a button or something. And active self is a good way to check whether or not that a specific object is active at the moment. Are there any questions so far, I suppose? I would hope not, because that means I'm explaining it badly. Cool. All right, so past the transform and the game object, which are, one could say, the most simple components in any game engine, really, we start going over some engine-specific things. So Unity implements its physics engine with rigid bodies and colliders. So let me go over how to access those right now. So rigid body can be referenced like this. So rigid body RB. It is not inherent to the transform or the game object, I believe. So you will have to reference it somehow, either with getComponent or with dragging it into the inspector directly. And what you can do with a rigid body, two of the things that I use the most are rigid body.velocity, which represents the speed and direction at which the rigid body is going. So for example, if you wanted to make the rigid body go upwards, you would assign a vector3, which is the container for numbers that I discussed earlier. And you'd want to go upwards, so it would go... Sorry, I should put this in update. It would go 1 unit per second in the upwards direction, which in Unity is y. So that's one way to use velocity. And another thing is add force. So unlike velocity, which is a constant speed at which the rigid body moves at, add force adds like a physical, or simulates a physical force onto that rigid body. So for example, if you wanted to simulate gravity, without using the use gravity checkbox in the rigid body, you would add a force of, you could add a downwards force to that rigid body. So if I were to put a vector3 here, since add force also takes a vector3, because most of the rigid body functions concern movement, it will often be movement in the three-dimensional space that Unity takes up. New vector3, if you want to go downwards, you do 0, like -5, and 0. And putting this in the update function will constantly add a force of that strength to whatever rigid body this is. So it's one way to add motion through script rather than, let's say, through animation, for example. So apart from that, there's also the collider. So unlike the rigid body, the collider and its various children aren't really referenced in most cases within a script, or at least at a basic level. An important thing to note, though, is a method called, or two methods called onCollisionEnter. Sorry. OnCollisionEnter and on trigger enter. So on collision enter and on trigger enter are ways for you to add things that happen when two bodies collide with each other. So the difference between the two is that on collision enter works off of a basic collider, which is physical and things can't go through it. And on trigger enter works off trigger colliders, which are, in a sense, transparent. In order to use on collision enter and on trigger enter, the script, the game object that this script is attached to, also needs to have a collider attached to it. And one of the collision objects needs to have a rigid body. Otherwise, the physics engine doesn't work. But with on collision enter and on trigger enter, you can take the collision data in the case of on collision enter, and then adjust maybe some variables on one of the objects that was collided to. So for example, if you wanted to destroy the object with the sample script after a physical collision, you could do this.gameObject.setActive false. So get mouse button 0 will detect whether or not the mouse button is being pressed. Cool. And the last thing I'm going to go over with for the purposes of this workshop is the cursor. So you can reference the cursor directly in Unity scripts. And this is mainly useful for if you don't want the cursor to be shown, or if you want to lock it to a specific, if you want to lock it to a specific position, which in most cases is the middle of the screen. So the way you do that is with cursor.lockState. And with this, you can set the mouse cursor to a cursor lock mode of none, confined, or locked. So none means it's not restricted like the mouse is right now. Confined means it's stuck within the game window. And locked means it's locked to the center of the game window, like how a first-person game would do it. Cool. So setting it to, if I set it to locked, for example, and I put this line of code into the start method, and I ran the scene, oh no, my cursor's gone. I can't move it. So yeah, cursor mode. Locking your cursor with the cursor mode will hide your cursor and prevent you from moving it. So we'll go over that later. But we'll go over that in a second. So, oh yes, one other thing to cover with input is the concept of get access. So, get access. So get access refers to, in the input sense, refers to a horizontal or a vertical axis, which may be best described with like a controller joystick. If you hold your joystick up, it's going up on the vertical axis, and if you hold it left, it's going left on the horizontal axis. And you can reference that in scripts by using getAxis. You need to input the axis name, which in Unity is default to horizontal or vertical. And this will give you the values that the axis is currently reading from any inputs that you might have. So if you don't have a controller, your getAxis horizontal is automatically set to the left and right keys and the A and D keys. And if you're using vertical, they're automatically set to the up and down arrows and the W and S keys. And we'll go over how to implement this in a second. Any questions before I move on to the last basic topic? Cool. Okay, the last thing I want to go over is raycasting. So a ray is a straight line that you cast or kind of fire somewhere. And raycasting is useful for basically interacting with things in a game. And the basic way to call a raycast is to do physics, which is the library. The method is called raycast. And it takes in three inputs that I'm going to cover. So the first thing it needs is the position that the raycast is going to come from. So if I were to do vector 3 dot 0, which gives you a 0, 0, 0 container, it will originate from the 0, 0, 0 3D position. All right, so let's go over the activity, which is a sample first-person shooter. So I'm going to use most everything I just discussed to create a first-person, a script that allows you to A, move something, B, shoot things, and C, move the camera around. So let me close this and create a new script. Yeah, don't worry about this. Those are helper scripts that I've created for you for the purposes of the activity. But for the main controlling script for the player, I'd like you to code that along with me. So let me make a C# script, and I'm going to call this. I'm just going to call this player for simplicity. You can name it whatever you want. And I'll open it. So that is technically true. For the purposes of this demonstration, I am going to use rigid body. So I'm going to reference a rigid body here. Okay. One thing I realized I forgot to go over is that you can also reference your camera. So if you type in camera, you'll be able to reference it later once you get the component. Speaking of which, because you want to access the player's rigid body, how would you do that, and in which monobehavior method would you reference? Yes, that's right, in start. So within start, what am I calling to get this rigid body? Yes, right. So that is right. You don't actually have to do this like game object because monobehavior inherits from game object. You can actually just call get component directly, and it'll know that you're talking about the object that you're on right now because it's the script. So you can just type in get component rigid body. So we want to shoot things. If we simplify the fact that like a projectile shot is like a physical object and reduce it down to what most first-person shooters use and just make it like an instant hit, we are calling a raycast, correct? Cool. So physics dot raycast. All right. So in a game, in a shooter game, where is your bullet coming from? Like in a physical sense, I suppose. So imagine you're like playing Overwatch or something in front of your computer. Where is your bullet coming from? Center. Yeah, the center, your crosshair, right? Yeah, the crosshair, right? So in this case, then, the center of your crosshair would be the position of your camera. So you would set the initial position to be your camera's position, which is why we referenced it. So cam dot transform, because you need to reference the transform in order to get the position. Yeah. Cool. So what about the direction that it goes? Yes, but you just said transform.rotation. Yes, but okay, so think about that physically. So let's see. Think about that physically. If you were to use the rotation value of the camera, what direction is 0, 0, 0, for example?
Right, because players rotate, but the camera relative to the player model will be rotating. So that would cause it to not trajectory.
That's not really what I'm going for here, but let me turn on gizmos. So let's say that my camera is not rotated. It has a rotation of 0, 0, 0. If I were to use that rotation 0, 0, 0 for the direction in which the bullet is being shot, it wouldn't go anywhere because 0, 0, 0 is not a direction, right? there are no values on any of the axes. So you wouldn't use the rotation. Um, Instead, you would want to use. Where is it? Where is the camera? Instead, you'd want to use the forward of the camera's transform, because logically, because you're shooting straight ahead, you are shooting forward, right? And that acts as your direction. So let me go back, and I'll do cam.transform. So you could calculate the forward direction somehow, but thankfully Unity is nice, and it allows you to just do dot forward. And this works for transforms, and this also works for the up direction as well. So that's pretty nice. Okay. Lastly, we want to check if it hits something, because we want something to happen when that gets hit, right? So out, raycast hit, hit. Oh, right. So if we get that hit in, we'll have some raycast hit stuff. We'll have some hit info for the raycast. And the way we can use that actually is in another if statement. So one thing you can do is if hit dot collider, for example. You can do equals equals null. So you can do if hit dot collider is not null. This means that you have in fact hit a collider, which is cool. Shootable shot equals that. X. So if you do it like that, you can just call shot here. So similar to hit.collider is not equal to null, you can put scripts or classes as the sole thing of an if statement, and if it's null, then it'll just return false. But if it has something, it'll return true. So in this case, what we're basically saying is if what you hit does not have has the shootable component, it'll do something else. So I think that's the last thing we're going to go over today. So let's do this camera movement. Cool. So we have the reference to our camera. Now we just need to make it move. Like, what do we need to do to the camera to make it look around? In order for the camera to look around, you'd want to rotate the camera because it's not physically moving positions. This screen is weird. Okay. So in order to do that, we actually need to child the camera to our player, right? So I'm going to go into the scene, which I've appropriately named Shooty. Save. Yeah, you'll notice that there's like kind of a shooting range type thing. And it comes with a player, which is great. So this player already has the camera childed. It has a collider and a rigid body, so you can move around. And it has a missing script. Oh, is this what you're talking about?
Yeah, when you're horizontally rotating, you want to rotate.
No, is this missing script you're talking about?
Yeah, I got it.
Yes, I know. Oh, so this is because I removed the script that I had initially coded for this. So.
I removed the component, and then I tried putting the script back in separately, and it's getting the error. So
Interesting.
but I think it's just because I had another script named player elsewhere in the project.
Cool. All right, so we have this player that is conveniently made for you by me. Thank you. You're welcome. And we have the camera childed to it, which is great. I've also included a crosshair so you know where you're shooting. So that's useful. The rigid body is what enables like physics. Okay. So it handles stuff like force. That's why it has add force. It handles stuff like velocity, which is why it has velocity. The difference between the rigid body and the transform is that the transform represents the object in the virtual space. So that's why it contains the position and rotation, because those don't necessarily correlate with physics. But with the rigid body, add force and velocity are correlated to how it may bounce off against something, for example, or is pushed by something. So mouse space X, and which where would I put this value where we're rotating it? X, Y, or Z? Probably Y. Okay, that's
So that'd be the second one.
yes.
0.
So now we have all of these, and we can test our player, right? So let's do that. Oh, I forgot to cover something. That's right. So besides shooting, sometimes in games you want to interact with things, and that usually warrants a different key than left click. Based on what I did for shooting, if I were to give me a key for like interaction, like if you want to open the door, you want to do right click? Okay, great, cool. Yeah, I mean, that is cursed. You are right, but we're gonna do it on his suggestion. So I'm gonna copy this whole thing, and I'm gonna call this interaction. And this is a way to differentiate between, I guess, what you're using to input and I guess what you're interacting with. So you could, in theory, put everything on get mouse button down, 0, and left click, and have multiple checks to see if it's whether or not it's a shootable or whether or not it's what's this one called? If it's a shootable or whether or not it's interactable, which I named it. So this is our 4-action. This is our 4-action player. So let's see how it works. Yeah.
Before we start,
Yeah.
wouldn't it make sense, I guess, for like code clarity to separate each of those different like parts of the player controller to like have a script for like movement and then have a script for shooting, have a script for interacting, or
So I think that depends on how you design your workflow. Because if you're talking about clarity, it is technically easier to see everything on one script.
that's true.
But there are different ways of structuring how you write. For example, with the way you suggest with separating functions into different scripts, that is applicable in the sense that you can edit one function without having to go through a bunch. This is particularly useful when your script is not like, how many lines is what we just wrote? Like 100 maybe? It's different when you have like maybe 1,000 line script, yeah. And it could also help you trace the function calls for multiple scripts. At the same time, it also makes it so that you have to look through multiple scripts to find that issue. So it depends on the function that or the game mechanic, I'll say it like that. It depends on the game mechanic that you want to implement, and it just relies on how you want to approach implementing that. So my advice is whatever works best for you. Yeah. So in this case, I'm avoiding creating multiple scripts. So I just want to go over. Yeah, I just want to go over like. But you can do it that way. Yeah. It is a valid way to do it. So I'm gonna put player here, and right. We'll test it. Okay. There is no camera attached to the player. That's right, because I didn't put get component in children. If you want a component that's in a child that's not on your object itself, you can use something called get component in children, and it will return the first instance of this component. So because there's only one camera as a child of our object, it'll give us that camera. In most cases, though, you probably want to manually assign it. So, but in this case, we're making it simple. Did I not save that? Okay, save. So if we play this now, I shouldn't get any errors unless I wrote something wrong. Oh, I didn't put a space. I'm not going crazy. All right. With no errors, we can see that we are, in fact, moving our player. But our cursor is still active, and it doesn't seem to be moving correctly. And if we try WASD, so W, I'm moving forward, which is great. I'm moving left and right, which is also great. So, what's wrong?
Up and down.
Okay, what else is wrong?
Mouse. Really, really slow.
Well, technically it's implementation, but functionally what's wrong? Exactly. So we forgot to lock the cursor. So in first person games, you often want to lock the cursor so it's not like that until maybe you pause the game or something. But in this case, we're gonna keep it locked. So cursor dot lock state equals cursor lock mode and locked, right? Because we want it to be locked. So let's set it to that. You said the up and down was inverted. So the simplest way we can fix that is just by doing negative. So let's try that. Okay, so once we click in, this is great. We are moving it like a first-person shooter would. Left is left, right is right, up is up, and down is down. Okay, let's try moving our guy. So we want to move this, right? So let's say we want to move forward. Oh, forward is not right. Because we're looking that way, and I'm doing W and S, but forward doesn't seem to be right, yeah? So for that, let me just check. Yeah, so why might that be? And I don't really... Oh, yeah, so why might that be with respect to our current script? I don't really expect... There's one thing I don't expect people to get right, but let's see. So why might the movement not correlate with how we're looking? If we look at the camera movement alongside the player movement. Oops. So let me put those together so it's easier to look at. Let me label this player movement. Camera look. So why might that be wrong? Here we have our forward movement set as 0, 0 vertical, right? But that'll give a constant value of 0, 0, 1. And that's with respect to the global values, like you said. So in order to fix that, instead of a new vector 3, we want to take input.getAxis vertical, and we want to multiply it by... So what if we want, for forward movement, what direction, like simply speaking, do we want the player to go? Forward, right? That's not right. And with respect to this player, let me switch to the camera. Oh, that's the canvas. Oops. So, and let me show the local. Okay. So, given that the forward vector of the camera is the blue arrow, why is the camera forward not correct? It's the forward of the player. Because we're rotating the player wherever we want the camera to look. So, but we're not actually tilting the player downwards and upwards. So this would be a good way to... This would be a good direction to use. That is not right. So instead of this, we want to do times transform dot forward. Okay. So what you said about global local space also applies to the side-side movement. But the difference is there is no transform.left or transform.right, I believe. Let me verify that to make sure. No, there is a transform.right. Okay, so we can use transform.right. Yes. Or keep it correct in case that's wrong somehow. So yeah, I was gonna go over, there's something called a cross product. Okay, so once we change this, let's try playing our guy. Okay, so as we move and I do WASD, you'll see that I'm finally moving with respect to the players forward and right. So if I tilt this way, I'll also be able to move in those correct directions, which is great. So this is our movement and camera movement of our player working. Now let's test the interaction. So the keys we designated are left click and right click, right? So the way I've set up this is that if you did it correctly, you should have a like faux shooting range where you can shoot 30 guys. And let me, for the purposes of like showing stuff, let me maximize the game view. So the green button here has a interactable script. So we'd want to use the interact button, which we've set as right click, right? And the enemies that should show up will have the shootable script, which is left click. So let's try that. Let me right click this and see what happens. Is that? And if I'm left clicking, you'll see I'm shooting the guy, and your score is counted on the side. This is aim labs, exactly. I made aim labs. I made you guys make aim labs. So yeah, this should be the end result of everything that I made you just go through. So this is a working, moving player that can shoot red guys and interact with green things. It's not that simple, I guess, but that's how it be. Cool. So that is how to make a sample first-person shooter player. I hope that you learned something from that. And if you have any more questions, feel free to reach out to me. And if you want to, you can also feel free to mess with the various scripts that I put. I suppose since we have like 5 minutes, I can talk about them real quick. The interactable and shootable scripts just have a public method called interacted and shoot and shot, and that's called by your player, as we demonstrated earlier. The way the scoring works is that it uses a shoot score script that has references to like text that you'd see in the real world, and the spawner script, which I'll go over later. And every time you, let me go to shootable. Every time you shoot something, it will increment the score that is shown, which is why you're seeing the score go up. And the spawner script will spawn objects within a random bounds that I've set. So in this case, they're hard-coded, but hopefully with what I've taught you so far, you can more easily read some of the code that I've put in here. Some methods that I may not have covered are stuff like invoke repeating, which is to constantly repeat one function over a certain amount of time, and within a certain like timed intervals. And GameObject.instantiate, which will place an object into a Unity scene without you having to drag it in, so automatically. As well as coroutines, but that's much more advanced. But yeah, that is the C# Unity P2P. Thanks for attending. I hope you learned something.